Guys, installed Hive? Anyone has installed and got the issue? One tried. Only one person tried.
Arvind,
Hmm.
installed but did not get any issues.
Okay. Okay. So you installed. Okay. Anyone else tried?
Yes, Arvind, I did install. Uh,
Okay. If anybody is getting difficulty, can ask these two person. Okay. In the group. Okay. So I want like everyone should install by Monday. So I can ask anything to show the Hive. Okay. If anybody has not installed, so please install by Monday. Monday, I want to check. I can randomly ask anyone. So Hadoop and Hive, these two, because without Hadoop, you cannot install Hive. Okay, so next is today I'm going to tell about map site join and reduce site join, and I will tell about basics of Hive, starting of the Hive. Okay. Okay, so so in MapReduce, there are two types of join. Map site join and reduce site join. So map site join, yesterday I was explaining this is the map site join. Okay. So map site join, you guys understood theoretically, right? What happens, right, when the one data set is very large. Okay. So this is like this emp.txt file. It is a large data set. Okay. It's a large data set. And one data set is very small, just KBs of data, okay, like department ID, department name. So hardly 10 to 15 departments will be there in the organization, right? So it will be hardly some KBs of data, and this is maybe GBs of data. Okay. So one is a large and one is a small data set. So the map site join is basically this particular data set is loaded through the memory. Okay, so in MapReduce, there is a concept of distributed cache. Distributed cache. So we are loading data. We are loading data through cache. Okay, so cache is basically a temporary, right? You are storing the data in some directory. You are loading a file in a directory. You are file, writing a file in some Hadoop directory location or local. Okay. Location, and from there you are reading as so we are reading a file, and then we are doing join with the last data set in mapper class. So why its name is map site join? Because joining is happening at mapper class. There is no need of register. So if you see here, employee ID, employee name, department ID. So the common column is the department ID. So we are making it join with department ID. So I'm going to show the code how it is. So for map side join, I have only one driver class and one map side mapper class. So we don't need any reducer class because joining is at the mapper side. So driver class, we are loading the data, right? We are having one emp.txt and one data is department.txt. So if you see here in the job configuration, so job configuration here, like I'm setting the distributed cache dot add cache file. My Hadoop directory, I have the department underscore txt file, and this file location I'm providing. So I'm providing my location of the file. Okay, this data will be shared to memory. Okay. So once this distributed cache dot add cache file, I'm providing the my file location. Okay. And the other file I'm giving through the as a input format. So that we know, right? Right, how to give the input format. So file input format, we are setting the arg0. So this the first number path is a my emp.txt file path. Okay. And if you are seeing, if you are not using any reducer, so what we need to change here, the job dot set num reduce task, we have to make it 0 because it is a mapper only job. It is a mapper only job. So only mapper class you will set. So reduce task, you will make it 0. You will not set any reducer class and other things as it is. Okay. So this program is basically setting the distributed cache. Okay. And the second thing is number reduced task is 0. Okay. So if you see it's map side join, like here mapper class is there. This is the mapper class. So in the mapper class, so if you see in the mapper class, if we leave this down, so here is in the setup function, one setup function is there. This setup function, we are reading the department.txt file. So I'm finding the all cache file because distributed cache is a common location. Whatever I'm setting in the driver, I can get in the mapper that cache file. Okay. So first I'm going to get all the cache file. So suppose there are the 4-5 cache files are there. So I'm checking with my department.txt cache file, right? If my department.txt cache file is matches, I say, I want to particular this department.txt file. I want to read the data. I want to matching the department.txt and calling one function load hash map. So this is a like function, and this function I'm passing the file path and context variable. The context, it's a common variable. I already explained about the context. The context is a shared variable, which is across the cluster is sharing the data from the mapper to shuffle and sort to reducer. That is the data, right? Across the machine. So here we are writing a Java logic. It is purely Java logic, right? How to read a file. So if you know about some input-output file APIs, okay? So input-output file APIs, we are reading a buffer reader and file reader. We are reading the file. So in this department.txt, I have a data, something like department ID, department name. I already explained, right? This one. So I'm just getting the data. I'm reading this file and putting into one hash map. The department map is my hash map. It is my hash map. If I see this hash map, so I have defined one hash map where key value pair I will store. If you see, this hash map is defined like this. This is the hash map. The hash map in Java is a key value pair. Okay, it is a key value pair. The string is a key and value is a string. The department ID is string. Department name is value. That is also a string. Okay. So I'm writing the data as a department ID. So how I'm writing it? The department map dot put. I'm writing write my array of 0. my index 0, because when I'm splitting the data, I will get an array, right? So array of 0 is my first index. That is my department ID, and the department field array of 1, that is my value, that is my department name. I'm writing as a key value. Okay. And this hash map I'm returning, from the my code. Okay. So I'm preparing this hash map, and this hash map I'm calling here, this one, in the map function. In the map function, what I'm doing here, I'm getting the value from this hash map. This hash map, I'm passing the last column. What is my last column? So here are the 6 values are there. So here are the department ID, department name. I'll show to you data. The department ID, department name, employee ID, employee name, employee city, like this 6 column is there. So last 6 column is a department ID column. So department ID column I'm passing and getting the department name, and then I'm concatenating the one string. And this string I'm writing to the context. This will be my final output. Okay. So this output is coming from the mapper. So your output file name will be part-m. Your output file name will be something like this, part-m-000, because this output file is coming from the mapper. Okay. So this is the logic, okay, for running a mapreduce job. Okay. Okay, let me show you where is my emp.txt file. Okay. So if I show you this location, so it's in I already have in my Hadoop. Okay, little bit is tricky, but you can understand, right? I'm saying theoretically you understand, like you can explain anyone the concept, right? What is a map site join? Because this map site join is common concept in Hive will come. Okay, same concept is there in Hive. Okay, so you should know the concept, right? So at least concept you should know. How it is implemented, it's a different here in MapReduce, we are using distributed cache to implement. In Hive, we go, there is a, like we have some converter properties are here, we have to set it. Okay. And if you're going in the Spark, so Spark, you will see this is implemented by broadcast job. Okay. So distributed, this map site join is basically different ways implemented in the Hive, in the Spark, in the MapReduce. Okay. But concept wise, it is same. So Hadoop address minus ls. So if you see my department.txt is here. If I see directly here WC, some employee.tsv file is there. Okay. So what employee.tsv file? This file is my the last data set. If I want to see this file, can you see this file? So this file has, this is a employee ID, some date of birth, first name, last name, gender, date of joining, or this. These are the different columns are there, and this is last is a department ID. And when we look at department.txt, department.txt has department ID and department name. So if I want to see, this one is the department.txt. Only 2 columns will be there, department ID and department name. So department ID D001, marketing is there, D004 is production is there, D005 is development is there, D009 is customer service is there, but there is no employee here, D009. Okay. So whatever record is matching here, only that department will come. Okay. So how looks my final output? Okay. So first we have to create a job. Okay. The same thing we have to do. So we have to create a job and then we have to do the Hadoop job command to run our job. Okay. So this job will copy. Okay, so here I start from the. So here so Hadoop job, what is the job name? It's mapreduce WC snapshot job. What is the next thing? My driver class. So what is my driver class now? This is my driver. So this is my driver class. Driver. What is the package? org.example. org.example. So this is class. Then next is I have to give input path. So I have to so my input path I have to see where is my employee.txt file. I have to give that location. So my employee.txt file is this is my file. I will give this location. And this is a Hadoop location. I have already uploaded. Okay. But in your case, you have to create a one directory and there you upload this employee.tsv file. And the same directory, just create a DC folder and keep it this file. Okay. So why we are keeping it this location? Because this location we are using in our code. Because if your file is not in this location, you will get error. So either you have to change your Hadoop directory, you have to change your Hadoop directory for your distributed cache, this directory. So accordingly, you change. If you want to change other directory, you can change. Okay. So you can change. Otherwise, you can if you can keep it same, then create the same in your Hadoop file system. You create your own Hadoop file system. So the employee TSV file and output location, I have to give new, right? You know, we have to give output location, we have to give new. So already some output directory is already created. Okay. You have seen here output 1, output 2, output 3, 5, these are already created. So something I have to give new, I can give output 10, anything you can give, or you can delete earlier one. But in your case, anything is fine because it will be a new. So now I run the Hadoop job. My output data will be coming as a concatenated data, right? The employee and department data will come as a concatenated, right? So I will get the data, right? Like this concatenated data, I will get it. Okay, comma delimited data, I will get it. So that is basically the output of. So my I can check here is done. So first I check this particular directory, what is the output folder is created with fs minus ls output. So here in this output 10 will come because I created output 10. So output 10 you can see. And in this output 10, what will be your file name? What I told you, right? What will be the file name? What will be the file name created inside this? Because it's a map side join, the output is coming from the mapper. So file name will be part-m-000, not part R, right? That is the difference. Okay. So automatically the file name will be part n. To see this data, look at this minus test. Part n file as the data. So this is actually I use a tab separated. If you see in the code, if I want to use a comma delimited separation of the data in my output data, you have to use the comma delimited, but I'm using a tab separate. Okay. So if you change this /t to comma, so your data will come as a CSV file data, as a comma delimited data. It is coming or not, department ID is coming and last is coming department name, right? It is coming. So this way we can do the join. Join means you understand, right? See, why I'm telling is mapreduce is not important, but concept is important. Okay. Because the mapreduce entire Hadoop is using the mapreduce internally, right? So if you understand well how mapreduce works, so you can understand any component of Hadoop. Any component of Hadoop you can understand, whether it's a scoop, hive, because everything is generating mapreduce internally. Okay. So practically, if you are not able to do, but at least theoretically you understand what is the meaning of join, okay, how the join is happening. In SQL, what is this type of join? Can you tell me what is the name of the join you do in SQL? What is the name of the join you call it? When you do this kind of join in SQL, what you call it?
I think inner join.
Yes, inner join. The inner join is like a one common column, and based on common column, you are getting the data from both the data set. That's there are the 5 or 6 joins are there: inner join, left outer, right outer, pull outer, cross join, self join. These are the different types of join. So these joins will be coming in Hive as well. These joins will be coming in the Spark as well. Because SQL, wherever the SQL is coming, all these joins will be there. Okay? But MapReduce having this map side join and the reduce side join. So this map side join, if you see, it's just like a inner join only, but it's one small data set and one large data set. So we can do the join like the data which is fit into the memory. So you can set the data in the memory, right? So you can use a distributed cache. So reduce side join, the scenario is one person has many orders, right? I say one is order and transactions. Okay. So if I say my data set is order and data sets, the transactions are there. Okay. So now I'm going to tell about second join, that is a reduce side join. First of all, the reduce side join is happening. Reduce side join is happening in the both the data sets are large. Okay. So reduce side join is both data set are large. But here I can say distributed cache is a common concept. Still, I have some small data. Like, okay, small data can come anywhere. In the map side join, it can come, or it can come in the reduce side join also. So I say if two data sets are large and one more third data set, which is small. Okay. Or this third data set is not there. Okay. This third data set, which I'm talking about, is a small data set. Generally, this data set is lookup data set. It is called lookup. So generally, why we need a lookup data set? You know, sometimes you have a country table and country is having a country code and country name, right? Country code, country name. Sometimes you have seen the table like currency code and currency country. Okay, which country this currency is there, currency code, right? So these are the like code abbreviations are there, right? Generally, and state code, state name, right? So what is the purpose of these are the master data? These are the master tables. They are, see, currencies will not come tomorrow, a new currency, right? Because already the countries are there in place, right? No new country will come tomorrow. New state will not come in a country tomorrow. Okay. So these are called master data. When I say the master data, the data will not change. So generally, when I'm just using this third data set, which is a small data set, so I need a sometimes lookup things I have to do. Okay. So state code, state name is there. Okay. Or currency code, country name is there. This kind of lookups is needed. So we will use the distributed cache. We don't need to load the data manually as a input parameter. Okay. So that is the purpose of using this lookup data set as a distributed cache. Distributed cache. Okay. Just they have given a name as a distributed cache. The purpose of this cache file is when the data set is really very small. Okay. And it is used for lookup data. Lookup data, like suppose I want to find some country based on the country code. So I can use this data set. But I'm saying reduce side join, this distributed cache is common. It can be used in the reduce side join or it can be used in the map side join. But I'm saying my data set, two data set is still large, right? Okay. So I'm saying like I have a order data set, and one is transactions areas. So if I say number of orders and transaction data sets near about equal, right? Okay, orders may be little less, but transactions will be more. Like one person has two orders, right? Order ID 1, order ID 1 and 2. Okay. So if I say same person, like two orders are there, but okay, two orders and okay, or I can say order, I can take it customer. So customer and transactions I take it. Okay. So one customer can have many transactions, right? Like customer ID 1 has this 10001 and he's with the customer ID 1 transaction and the cost of this transaction is suppose $56. Okay. Another 1002 transaction that is also belong to the customer ID 1 and this transaction is 3420. And another transaction is there 11003 and this is customer ID 2. Okay. And this transaction is only 1. Okay. So if what is the use case here? So I want to calculate customer total cost. So if I say I want to print like this, like customer ID, customer name also I can print. So customer name here will be also. So customer name is here X, the customer name is here Y. I want to print customer ID, customer name, and total cost of order. So here I say 1 and I find here is name X and 90. Okay. So this is my total. Second one is a 2 and I'll say Y and I say here 23. So it's only one cost. And I want to print the total number of orders also, count. So I say I want to find the count of transactions. So here is a 2 and here is a 1. So I'm talking about here, I have a one data set this and second data set is this and I want this. Okay. So here is no lookup is needed. It is simply two data set join, right? If something is needed as a lookup, suppose I'm having a data is a credit card data is there, like online transaction or debit card transaction, credit card transaction. So like different transactions code are there, like okay, payment gateways. Okay. So payment gateways, I can make it lookup. Okay. But I'm making it very simple example. I'm saying like I have a two data set, customer and transactions, and I want to find the customer wise. So I'm saying this customer will not be a small, this transaction will not be a small, because if I'm saying if one customer has one transaction, okay, so definitely the customer and transaction will have near about same size of the data, right? Transaction little bit more because some customers can have multiple transactions and some customers can have only one transaction or some customers cannot have any transaction. So that could be a scenario. So I'm assuming both are the not small, both will be near about same, right? So reduce side join is basically the join is happening where the join is happening. Reducer side join is happening here in the reducer. So here I have to read two mapper class. So one mapper will be customer mapper, and one mapper is the transaction mapper. Earlier you were reading only one mapper, right? Because map side join has one mapper because it's a mapper side join. But now you have a two mapper, and these are the two different data sets. This is a customer type and this is a transaction type because both are not same, right? So that is the reason we are going to read two mappers. Okay. And when we are reading the customer mapper, so we will be add the prefix in my output data, right? Key value pair. In my key value pair data, I will add in the key in the value. In the value part, I will add cust underscore value. Why I'm adding it? Because when the data will go to the reducer, we can identify this is a customer data or this is a transaction data. So when the transaction data I will be sending to the reducer, it will be going like a so something like identification. I'm sending a prefix. Okay. And when I will come to the reducer here, okay. So in reducer, I will be checking first whether the data is a customer type or transaction type. If I find the customer type, so I will take the ID and name, and the value type, then I will take the cost and I will add the sum. Okay. And then I will print the customer ID, customer name, and total cost transaction. Okay. You will see by code, it will be very easy. Okay. To understand how the same thing, what I'm explaining to you, how it is happening. So when you look at the code here, so this examples I have in my this class. Only one single class I have written. Why this time I single? I just want to show you even we can write a multiple classes in a one single class also, right? Like mapper class. So we have to create an inner class. Concept of inner class, like you can create one single class, and this class is a driver class only, but other classes are the static inner class. So how many total classes are there? One, two mapper classes I told, customer mapper, transaction mapper, and reduce side join reducer. This is a reducer class. Okay, this is a reducer class, and this class itself is a driver. So this class is itself is a driver. I don't need to create a separate driver class because I have created a main function. Is it clear this thing? Okay. So first of all, what I'm going to do here, I have to, I'm reading a two mapper classes, right? So here, if you see, I'm adding a customer mapper and transaction mapper. So I'm using multiple input format. So previously we were using simple input format. Okay. But this time I'm using a multiple input format and I'm adding the both the path. Okay. So I'm adding both the path of customer mapper file. So two files will be there. So definitely if I'm saying two mapper means two different files I'm going to read. So one file will be customer data and one file is the transaction data. Okay. So two files I'm reading as an input file. Okay. And output I'm creating a same as it is file output format. I'm creating a output path. So only change is here in the driver class. The change is we are using multiple input format type, and multiple input I'm giving the two input path. One input path for the mapper, customer mapper, and one for the transaction mapper. Okay. So rest of the other things are same, whatever you are doing. Okay. Okay. If you come here, first mapper, the logic is very simple logic. I'm checking here, whatever the records are there, data. Okay. Let me show you the data so you can get more. I will run the code locally. Okay. So I will show you the code locally so that you can see. We can. So here I'm giving the three files. One is a customer detail file. Second one is Second one is a transaction detail file. And third one is, this is the third one. Third one is my output path, right? Where I want to get my output. So there is a directory mapreduce WC. Is this directory I have all the files, okay? Go here. See here. So one file is data folder, this data. So this data folder, I have a customer detail, I have a transaction. I'm opening these two files. Customer detail, if you see here, this is the customer detail. So customer ID, customer first name, last name, age, and this is the designation. So these columns are not in use, like, but just I'm using in the data set. But if you see, this column is a mapping column. Okay, if you see 4001, here it is coming 40001. And if you see here, this is the transaction detail, like transaction ID, some ID will be there for the transaction. This is the transaction date, customer ID, and this is the order of the cost. Okay, and this is the other details is there. Okay, this is the credit, debit, right? Suppose if I'm using the, here some code I'm using, CR, like this is a CR. Okay? Here I'm using DB, debit, okay, CR. Suppose I'm using this one. So I want to print what is this CR, what is this DB. So what I need to use, I have to add one more file as a distributed cache file. So through distributed cache, you will use the code and type of payment gateway. Okay, if CR is there, credit card. If DB is there, debit card, right? So I will keep it there. So right now I want to print as it is. I don't want to change. Okay, so I will keep it whatever is done. So these two files are there in this data folder. Okay, and the last one is my output folder, and this output folder name I will change it. It will say done. So any name you can get, just we want to test our output. So some new directory should be there. So now I will run this class. Okay, in the same class, everything is there. Okay, everything is there. So here the logic, you understand what is the logic? Okay, I have not explained the logic. The logic is, first I'm going to split the column separated data, and I'm creating I'm writing in a context by part of 0. So what is this part of 0 in customer? Customer, if you see, part of 0 is customer ID. And what is the other column? If you are taking a customer ID here, so what you are adding, customer name we need, right? Customer ID and customer name. So what I did for customer name, in the value part, I add the part of 1. The part of 1 is, and I'm adding a prefix, plus CUST to the prefix, right? So I'm adding customer CUST, this name. These are the first name. I'm adding this name. Okay. And the second mapper is a transaction mapper. I'm splitting the data, comma separated data. And in the context, I'm writing part 2. So what is the part 2 here? If I look at the part 2, the part 0, part 1, and part 2. Same again, customer ID. Again, so I'm writing, because customer ID is unique, right? In the mapper and reduce these two mappers, what is the relationship is there? This customer ID, right? So this customer ID is a part of 2. And part of 3 is my cost. So I'm adding a part of 2 and part of 3. And I have given the prefix transaction, some keyword I given, so that I can identify my transaction. Okay. Now, when we come to reducer, here is a trick. Here, what I'm doing, I'm iterating all the list of values, because for the same key, you know the MapReduce word count concept, like same key has multiple values. The same thing will happen here. same key means same customer ID will have multiple values together, it will come, right? So when multiple value will come after the shuffling, so what will happen? So same key and this multiple values are related to same ID. But how can you identify this key is a customer or transaction? So here I'm checking it in the this like list of values, right? List of values I'm iterating, and there's the list of values I'm checking. I'm separating with the space and I'm checking whether it's a transaction type or customer type. If it is a transaction type, so definitely I have a cost. So I will take that cost. Okay. So here are the two parts. When you are getting a data, you are getting a data in two parts, right? If you have seen here, here are the two parts. When you are concatenating data, so this is the one part, and after space, you have the second part, right? The second part is a value is your amount, right? Okay. So when you are getting this, so part of this is the part of 0 and this is the part of 1. So you have to take it cost, right? So how will you take it the cost? Part of 1. So if you are splitting one value, so your value is look like this. Okay. Printing here, like I will get either the value t n x n and the space will be suppose 23.45, like this will come. Okay. Suppose when the customer name is coming, customer is there, so CUST space and name is something test. Okay. So when it will be identifying if it is a TNXN, then it will take the part of 1. This part it will take. Okay. And it will add in the total. So initially total start from 0. And suppose he has 3 order or 2 order. So first order this one, and second time again the TNXN come. So second order is the 63.6. So that will be added in the total. And count we are doing parallelly. So initially count is 0. Count is the integer and I'm doing count plus plus. So first time count is 0, second time is 1 and then 2. The total count will become 2 for the customer ID 1. Okay. If it is a customer, if it is this part 0 is a customer, I have to take it part of 1, that is the name of the customer. This name. And here I'm preparing a one string which is concatenated of the count and total, and I'm just writing it customer name and value. I'm typing it as a order and number of order and total cost. Okay. So your final output look like this. Okay, like this it will come. Okay, after the total. Okay, let's see output. I have already run. This code is run here. So my output is generated in the data folder. I have given this one, output reduce side join. If you come here, one part -r file is created, because why part -r? Because it's a reduced side join. So can you see customer name is test? Who is the customer name test? This customer 4001. How many orders are this guy? 2 orders, 45.67 and 78.67. So you can see this is a 124 is a total cost. Customer ID 2, test 2, this is the 4002, and 4002 only 4002 only one order. So how much it is amount? 89.90, and 4003 has only one order, it's 98.90. So can you see 89.90 and 98.90? Okay. And the one customer who has no order, the customer is there, the test 6, but he has 4004 has no matching record in the transaction. That is the reason it is coming 0 transaction and 0. So it is the same calculation or not? Right? So reduce side join is basically we are combining the data at the reducer end. We are identifying from which mapper the data is coming. Accordingly, we are combining the data. Okay. It's clear, everyone? Okay. So you can run this code same like I'm running. You can run even Hadoop also you can run. But if you want to run on the Hadoop cluster, there you have to load this files. So you have to, whatever your data folder, just provide this all path you have to provide. Okay. And here input path you have to give same as it is like this. So I will provide you this string. This is your this how you have to provide the input, plus how you are passing the parameter. So how you are passing the parameter, so that is I will give it to you, and then you can use if you are running on the Hadoop, so Hadoop jar and jar name, and this path will not be Hadoop path. Suppose this path you are using this path. So this path, suppose Hadoop path. So use Hadoop path. This is the first file. This is the second file. This is the second file. So you have to upload the data, and this is your output data. So this is the Hadoop directory output data. And before that, you have a driver class. The driver class is important. Driver class name is like com.example. This is my driver class is my main class. The main class is my driver class. This class is reduce item. So this single class itself is my driver. Okay. Everything inside this class, I have not created separate class. I've kept it all classes together in one single. So when you run like this, it will run in the Hadoop. So you can test the logic in the Hadoop. So same logic will work, because if your logic is working here, the same logic will work here. Okay. Okay, so this is the MapReduce completely done. Okay, so you have to revise the concept, right? So what we covered, so simple word count program architecture, MapReduce architecture. So in MapReduce, you can have this architecture, combiner, partitioner, and we have distributed cache concept and two joins, map side join and do side join. Theoretically, anybody is asking you, you have to explain this all. Okay. And if somebody is asking practically, you can tell the word count program here. You can explain in the matrix architecture on word count program. So there is a map function, reduce function. So you have to explain. Okay. So I'm not telling everything again. I'm just telling about what you can explain. So word count program architecture you can explain. Okay. Putting mapreduce architecture. Combiner, you can tell about combiner, partitioner, distributed cache, map side join, reduce side join. Okay, so next is Hive. So first thing is you have to complete the Hive installation. Okay. So Hive installation will be installed by Monday. Okay. If anybody gets a problem, so anyone can help volunteer. Okay. Those who have done. Okay. In the group, you can post it if anybody gets error. But I'm saying if still you are not able to fix it before Monday, you can ping me personally. Okay. I can connect and I can solve. But I want, first of all, the guy who is not able to install or who is getting error can ping the other guy who has like just ping in the group. Okay. I want you guys help each other. Okay. See, I will do, definitely I will do. But I want like you will be helping each other, so you will be learning. Right? It's your learning. Okay. But if you are not getting from anybody response, or you think like nobody is helping you in the group, you are not getting anybody's help, so you can ping me. Okay. On Monday, you can ping me, and I will connect on Monday, and I will resolve that. So if I'm telling you, if two guys installed successfully without any problem, so I believe, right, it is not difficult. So Hive is installed because this is a very important concept, because Hive is a SQL data warehouse. Okay, tool. The SQL data warehouse tool is like same like a SQL query, right? You can use a SQL query tool. Okay. And this tool is originally developed by Facebook. Okay. So originally developed by Facebook, and later on this one is given to the Apache. To given Apache. So now it's a Apache, the Hive, Apache Hive, we call it Apache Hive. Okay, and it's a SQL data warehouse tool. So first of all, definition of Hive is it's a SQL data warehouse tool. So then we can say what is the difference between the SQL and the Hive, right? Because if already SQLs are there, then why they need Hive, right? So we know SQL databases, I already explained this thing, like SQL databases are vertical scalable. They are not horizontal, vertical scalable. So the scalability is vertical. That means your data is cannot be shared across the machines. You can install one database on one machine. You cannot share the data across the machine. That was a limitation in the SQL. And SQL databases have limitation of the data size, right? Because beyond the machine capacity, you cannot store the data, right? But Apache Hive is distributed. Okay, it is basically distributing the data across the machine in a cluster. So basically Hadoop ecosystem, when I say Hadoop ecosystem, so Hadoop ecosystem is the one component, right? We have already seen HDFS and MapReduce, but the other component is there Hive as a SQL data warehouse. So when I say SQL and SQL data warehouse, so one difference is vertical scalability and horizontal scalability. But the other difference in the SQL database and Hive, okay, data warehouse, you can say. So SQL database, schema on write. Schema on write. So you know, right, whenever you are writing data in a SQL databases table, right? In the SQL databases table, you are writing data. Your schema will be checked. Your schema will be validated. What is a schema? Schema is whenever you are writing a table, data, suppose I say EMP table. So EMP table will have some columns, right? You say EMP ID is there, EMP name is there, right? EMP salary is there. So these are the columns. So these columns are having some data type. ID, I say integer type. Name is varchar type. So in SQL, the data types are there, right? So these data types is nothing but schema. That is schema. So when you are saying, when you are writing data in SQL table, your data is validated. Your schema is validated. Then only your data will be inserted. Okay. So it is a strict schema. It is a strict schema is there. It's strict scheme. Okay. But in the SQL, in the Hadoop Hive, by saying Hive is schema on read. Schema on read. The schema is checked, schema is validated at the time of SQL query, select query, at the time of select, not at the time of writing the data. So writing data is faster. Writing data is faster in Hive because it is not checking schema, it is dumping data into table. Okay. But when you write SQL query, select query, SQL select query, then it will check data types. So this concept is making a difference, right? Because that is the reason we say Hadoop is faster for writing data, okay, and while querying data, right, your data is coming from the distributed machines, right? So it's faster, and it's basically the logic is I talked about in Hadoop there is the block size, right? So you know, right, the block size is very large, right? Block size is 128 MB. So if your block size is 128 MB, so the data is on the Hadoop file system, right? Data is on Hadoop file system. So this table, you are able to see the table, right? In Hive, you are able to see data, but underlying data is stored in the file. So underlying data is stored in file. So do you know, right, in SQL databases also the data is stored in the file only, because we get interface, we get user interface as we get a user interface as a table, right? Row and columns, rows and columns. But actual data is stored in file. These files you cannot read. This is the difference. You cannot read their files because these are compressed files. But here is Hive, you are plain text file, you are right, CSV, JSON, XML. So that is the reason Hive is supporting all types of format data. Hive is supporting all types of format of data. We'll talk about this, right? CSV, JSON, XML, okay, Avro, ORC, Parquet. There are so many different format of data, all are supported. You can write the data into Hive table of these files. Okay. So I will talk about on Monday the first thing. You just brush up the things. Just go through the concept of Hive architecture. So how many components are there in the Hive? Okay, like mapreduce architecture, you've seen map and reduce and shuffle and sort. So Hive architecture, how many component in Hive? Hive CLI is there. Hive compiler is there. Parser is there. Hive parser. Hive execution engine. Hive database execution engine. And other one is a Hive script server is there. You will, and Hive main important one I have not written, that is the mapreduce DB. You remember, right, when they are configuring the mapreduce, so this mapreduce DB, which is storing your metadata. So Hive is actually divided into the two main parts. One is a Hive actual table data, actual data, and metadata. So metadata is stored in a separate table, and in this case, here is Derby. So Derby is a database, is a SQL DB. That is another separate database, only for metadata. And actual data is stored in Hadoop file system. Hadoop file system as file. Because Hadoop file system, there is no other way. Hadoop file system, it will be stored as file. Either you give the file, Hadoop file system file you give, or it will create automatically. It will create, like whenever you write the data, it will create file in the backend. I will show about this, and I will tell next concept is a Hive internal table, external table, internal and external table. And one more concept you see, Hive partitioning. Okay. So these concepts you can go through it. I'm just wrapping you the, even you can join that classroom link. I will give the link of that classroom. So you can see all the videos, okay? If you don't have those things. So this classroom link I giving to you here. For this one, if you see in the beginning here, so here you can see the Hive sessions. So here in the Hive session 1, session 2, 3, 4. So you can go through it, and here all the videos are attached. So I'm giving this code to you. You can join it. Okay. And this code you join, and then you can see the reference model. Okay. So just go through it. It will be more clear when I will be explaining practically, but do it before and do the installation. Okay. Anyone has any question? Yeah, thanks everyone. And we will do the class on Monday. Generally, I do weekend, but I'm initially not doing for you weekend because I want, like, you should first prepare your previous concepts, right? So prepare Hadoop, SDFS, and mapreduce. So this part you finish it and come to Hive. Okay. So you do the parallelly, otherwise you will be behind. I'm telling you. Okay, because now, and I have given the assignment. Okay, I'll just show you once again, because this assignment also I have given the date. So in your batch, the assignment is, this is the assignment. So nobody has taken this assignment. So this is the batch, and this batch you have to complete the assignment date is this. Still you have 1, 2, 3, 4, 5, 6. As soon as possible, you complete it. Okay, I giving more time because I'm keeping it today. MapReduce assignment I will be keeping it. So MapReduce and Hadoop both will be same day. Okay, so you have to complete both by February 1st. Okay. Okay. Anyone has any question? Ask me. Thanks.